So it's a great pleasure to be here in front of you. I was attending the very first user conference. And okay, as of today, I've got the pleasure to introduce you the Limiting Vaccine Wastage by Optimizing Health System Support presentation. So my name is Rafael Giro. I'm the founder of the MAHA organization. MAHA stands for Mapping and Analytics for Health Activities. I will be introducing you the probabilistic structural equation model. And this could be also broadened to a larger scope when we are dealing with public health programs such as malaria, TB, or whatever. It's a journey. I'm scratching just the surface of BioLab functionalities. I do not have any mathematical or statistician background. I'm a project manager, but it is such a user-friendly software. It could be very useful for this purpose, project management, and how to advise decision maker at the Ministry of Health level. Just to give you a quick background about our key services, one of our key clients is Vaccine Alliance. This is an international organization based at Geneva, and they are funding vaccines worldwide. And they were expecting from us just to set up basic static maps at the national level. So it's just the opportunity to locate some health facilities in specific districts. And very useful. When you bring back this type of information at the district level, people are very excited just to be able to locate where are the communities or the health facilities. The flagship GIS application is called Dynamic Map. This one has been used for the very first time in Yemen for a cholera outbreak, and you can have a quick appraisal about the key functionalities. You can select the indicators. You have a time slider. You have some drop-down list to select a particular district, and you have some corresponding graph related to the number of children vaccinated or the vaccine coverage, and okay, the thresholds for the variables. And there is one interesting features is the background layer. You can set up basic maps. So you have the opacity, and you can mix two types of information, two layers of information. And it's very purposeful when you give some analytical capabilities to decision makers, because you can visually correlate vaccine coverage, and it could be another type of maps. It's not the case. This one is just from open source map, OpenStreetMap, but the number of new cases. And you can play with different type of basic maps just to visually correlate when you zoom into a particular district, because you are in charge of this geographical area, and you mix information. It's a beginning of conditional probabilities, because you make this correlation. But it could be also proved mathematically. That's why Bayesian networks come into play. Another type of GIS services expected from the Ministry of Health, because they are thinking at the district level. At the current time now, they have 216 districts, and they would like to have the shapefile, which is useful for GIS software, at the sub-district level. So we have set up a GIS platform to delineate sub-districts, and we will come up with about 1,215 sub-districts. So you can see this is a sub-district, and we will be linking the location of communities with a particular health centers, because there are lots of strategies just to reach the children. That is called the REC strategy, reach every children. So far, there is a children which is not vaccinated. They have reached about 80% of vaccine coverage, okay, worldwide. but where is located this fifth children who is not vaccinated? And this is an opportunity to use this tool to better locate. Okay, back to the Bayesian network. This is a kind of conclusion. It's worth having it already from the very beginning of the presentation. And now I know that it works. Through the Bayesian network, you can come up with very relevant model, and you can easily identify where are the key drivers. But when you want to have a buying approach with the Ministry of Health, the previous network is meaningless from the decision makers. So you have to take into consideration their way of thinking. And you have here a very interesting approach called the performance framework or logical framework. And you have already a causal relationship between input, output, outcome, and impact health indicators. And they are working on a daily basis with this way of understanding what's going on the field. It's just a question of putting this arc between two variables, but they are not accustomed at all about this way of thinking. Another important conceptual framework for these people, it is called the WHO building blocks. I will further comment them. And it's just a question after that also to locate, this is a cluster of variables at the right place. And you start having the interest of your interlocutors. I give you a broadened perspective about the context. You have heard about the Sustainable Development Goals. So when we are dealing with the vaccine, it is the 3.8.1 related subject, and when we are dealing with the supply of medicines and vaccines. When I'm saying this, it's like even on Earth, if you are capable of putting some variables behind each of these themes, and you correlate or you try to have a causal model, if everything is achievable, we will be even on Earth. So it's just unbelievable how the United Nations are setting the targets about the world today. Just a quick reminder, and I like this slide because there is a keyword. We are facing an outbreak of cholera cases, measles cases, worldwide, and it's very obvious in Madagascar, for example, or in Ukraine. But this slide, you can see you have a keyword, cause, the same root cause, failure to vaccinate over many years. We are entering into a causal model that's very purposeful. About the challenge when I'm dealing with Bayesian network, so how could we appraise the complexity of an immunization program? Because you have lots of intertwined variables. And the solution for me is the theory of change and the use of Bayesian network, of course, as a modeling framework. Just to give you also a more accurate picture about our context, Vaccine Alliance is funding about $2 billion vaccine within 60 countries. And we will take benefit of this evaluation framework named theory of change or result chain. And we have to merge these two approaches. The top-down is through this conceptual approach, and there is a bottom-up approach because we can take benefit of lots of data sets. Now we have the health information system, which has been funded by the World Bank or the Global Fund, and nearly all the African countries are using it, and it is such a gold mine repository to take benefit of so many variables at the granular level. And when we are dealing with the Bayesian network, we do like a huge data set. It was a kind of mantra for me, the bigger, the better. I was not fearing dealing with huge data sets, thanks to the clustering approach and overall this, probabilistic structural model. More detail about the theory of change. This is typically the causal model used by Gavi when they are supplying the vaccines within a health system somewhere. They are trying to understand what's going on in the field through this conceptual framework. So I will be dealing with the SARA survey. SARA means Service Availability and Readiness Assessment, and I will take benefit of mainly inputs such as the type of training, the type of equipment, the availability of supplies and equipment, availability of healthcare. All these variables will be available within the data set, and after that, mixed with the also algorithm, we can come up with a very powerful model. Now dealing with the WHO building blocks, it's very useful to think in that way. You have the health workforce, the government's approach, all the information system, the service delivery, and this framework will be very much useful when I will be dealing with the forbidden arcs. So you are very accustomed with this visual, and dealing with the probabilistic structural equation model, I will use unsupervised algorithm. I will use the clustering approach and the supervised learning algorithm, so to characterize the targeted variables. Data source, once more, it was already explained. I will be dealing mainly with input and output indicators. It is a small part of the causal model. I'm not fearing about adding additional data sets related to outcomes, such as the vaccine coverage. It is not done in this study, or even mortality rate. But it's just a question of getting access to this type of data sets. About the data selection, I will go into further details later on, but the original data set I had, it's quite small in comparison of the previous presentation. I had 480 columns or replies of question and about 1,200 rows. Because I was very cautious about the quality of the data, at the end I took into consideration just 245 replies, mainly binary. So you can see these 245 variables through the spanning tree algorithm. And it's very useful because you can already focus on specific parts of the variables which could be of interest, thanks to this importance of the node and some thickness of the arc. So I was going through all this visual just to appraise what are the, I could say, spontaneous relationship among these variables. In regards to the scope of variables, I was focusing mainly on this power supply and the availability of generators, the importance of energy, especially for the cold chain. I will further talk about that. Child immunization, of course, the equipment, antenatal care. So I was focusing on this class of variables. About the targeted variable, so this is the calculation, because extracted from the information system, I had the number of doses used and doses wasted, and the number of children vaccinated. So I calculated what I've called wastage rate, corresponding to the number of vaccine doses used and wasted, divided by the number of children. It's not exactly the the definition of wastage rate as used by WHO, but because it is discretized after that, it doesn't matter. I've got a mean of 3.3, which is quite huge, and you will understand why later on, and the standard deviation. So when we are dealing with the BCG vaccine, it's quite usual that you have such a high rate of wastage. Unconnected network. So you are very accustomed with this. Nothing to say. It is. And about the class indicator, it was very interesting to have all this classification, because I will, through these classes, set up some forbidden arcs. And they have been grouped because of common features, of course. Just to give you some example, it was easy to merge all the replies of the question according to the energy or related to the cold storage, the service availability, and so on. And the forbidden arcs, because I did want to put some constraints in the model. So you can see this type of forbidden arcs. And supervised structural learning, very nicely show it. Interpretable layout. So till that time, it is useless to communicate through this type of model. That's why it's very purposeful to go through the clustering, and once more, through the mapping, you can appraise the importance of the node. And I've identified, for example, the energy power source or the trainings, the immunization services, of course. It starts becoming very much interesting when we cluster the variables. And I've forgotten to tell you, I take the example of the energy. I didn't put any constraints behind the energy, just to see where this availability of energy will be connected with. And we will see that later. Dendrogram is very useful also to visualize the association among the variables. The main subcomponent, so the cold chain, it's a key component when we are dealing with the immunization program. And because it's a very delicate product, especially at the national level. You could imagine if you have some constraints at the national level before spreading all the stocks at the lower level, something is happening at that level, it could spoil your whole network. The importance of the training also, because new vaccine, new technologies are proposed in the countries. People do need to be trained to properly vaccinate or to use new equipments. Latent factor, instead of having 91 variables, now through the cluster you have 11 dimensions. It's much more easy to communicate about this dimension, especially because it has a strong meaning. But it's the right time to think about, when you are using the Bayesian network, you do need a new mindset. And I don't know if I had this capability prior to the use of Bayesian network, BioLab, but you are compelled to apply a new way of thinking. When you have this type of comment, operational thinking, if you are in a position of a planner, you have to focus on the causality, and it is clearly stated in this sentence, and to take into consideration all the side effects of your decision through this subcomponent, through these building blocks. And Bayesian network is a true inference engine, and you can compute all this relationship because you have loop back. I keep on with this one because I found it the most relevant one, because through a latent factor, you can already tell a story. I didn't name the factor, but it is related to the temperature of the refrigerator. And you can see that it is closely connected with the energy, the training, no training, okay, the communication, energy here, the type of equipment. So when you are dealing with the temperature, just through this key variable, you can already have a kind of quality insurance. This is in the private business, this kind of word use. But when you are dealing with the proper equipment, you know that the maintenance, you have the right tool to repair your refrigerator. You have a tracking system about your temperature. You know how to report the issues to the right level. Through this temperature, through this latent factor, you can already tell a story about what's going on the field. Another type of latent factor, and it's very obvious for the WHO, they do not want to miss any opportunity to vaccinate the children. So you are supposed to open a vial, whatever the number of doses. In the case of BCG, you can have up to 20 potential doses into a single vial. So you can imagine when one children is coming, you are losing lots of potential doses. And this is a key issue, how to find the trade-off between the number of children coming to you for vaccination and the opportunity to open this vial. In fact, when you face some true situation on the field, it happens that the children are turned away because there are some constraints about some budget and so on. So look at this criteria: 85% contribution from malnutrition. I will further comment about this insight. It's a question, you know that the mothers are caring a lot about the children. They are capable of walking for kilometers just to bring their children to the right place to get supplementary feeding products and so on, or by bicycle. So it's just unbelievable how the mothers are motivated to reach that health center when they are aware of some healthcare services. So just to give you so far the context of this, why you have this level of contribution for the malnutrition. Maybe I will come up with a proposal later on. Here is the overall picture. It comes from your study report, in fact, Stefan. But just to give you, you cannot communicate through all these variables, too complicated. So I will focus on 11 factors and the yet to be connected targeted variable. Here comes the supervised learning algorithm. So it is possible to get the connection between the target variable with this whole environment, these 11 clustering factors. Nothing new. This one is quite simple, but it's very easy to explain. When you go to the true model with some covariates, this one is very simple. Here comes the very nice potential conclusion. I'll let you have a look about that, but it could be very meaningful for some people. When you are talking with the expert on the field, they will tell you it's common sense. When you are, let's take the example of the increase of the temperature of the refrigerator. Of course, if you go over a threshold, it spoils your vaccine, and this is a waste. So it is common sense. But through this type of graph, you can already quantify and you can give some priorities. I go into further details. So back to the malnutrition. It seems to me obvious now that if you increase the malnutrition session, you can also, at the same time, if you have one point of care, have some vaccination at the same time. So if you increase the number of malnutrition sessions at the same location that your vaccination service, you decrease the wastage rate. And this is the most important contributing factor to reduce this. So you can see you have this positive effect on your targets. It's now just a question of optimizing immunization session frequency with session of malnutrition session. Another type of positive effect is the number of computers. It's obvious. If you have this tool available, you can better quantify your needs of vaccines, or you can also better manage your stock. It is such a powerful means. And another type of example is the direct medicine supplier. If you can very easily and quickly order new vaccine because you have this type of relationship with your supplier, it applies to the medicine, but I just extrapolate into the vaccine field. You better manage your stock and you avoid any stock out. And just for the anecdote, in the case of Ghana, just to have the right quantity at the right place at the right location, they are using drone, but it is a test so far. Negative effects, of course, the stock out. You have to apply the earliest expiry first out principle, which is not hugely applied. Of course, it's very complicated because you have to master lots of information about the temperature. If you have some specific tool attached to a lot and you are capable of tracing the cumulative temperature over the discard point. So you should put it outside your stock as soon as you have a specific color in your tracking system. You are familiar with the quadrant scatter plot matrix. When you have this in front of you, it's very easy to decide where you should put your budget. So you have on the x-axis the importance of the factor and the effect, through direct effect on the targeted variables. So better to explain this through this type of conceptual diagram. You know, according to the location of your points, where you should put your attention. If you want quick wins, because it is located in this part, you know that you will have to supply little effort in terms of money or in terms of time to have a maximum effect on your targeted variable. And if you apply this type of diagram, you know where to act according to your priority. You have a GIS module in the BioLab, very useful. As soon as you have a GPS point, you can appraise the heterogeneity of the situation, because the previous matrix was of little use unless you are capable of having this breakout variable in terms of location. You want to pinpoint very particular geographical areas, and it will be done, I will show you later on, according to the type of management. In any health system, you have the governmental run organization or health facilities, or the private sector also is a major player, and NGO, non-governmental organization, also can manage a network of health facilities. So you can compare their performances against these breakout variables, and it starts to be much more interesting because you will be focusing on particular region. I take the example of, okay, this is without any selection of region, but if we go into the southwest region, we can already discriminate in a better manner where you should put your attention. And it's not by chance that the stockhouse, because they are in remote areas, they are facing lots of stockouts. So you can already explain, because thanks to your understanding about the situation in the field, why you have this location of clustered variables. This could be applied also at the district level, so you go at a more granular level. And you remember at the beginning, in Ghana, we are displaying the maps according to the sub-district. So you can go into very fine details as soon as you are capable to have this type of geographical information. And now the breakout variables is according to the type of organization. So in Malawi, we have a key player, Christian Health Association of Malawi, and this is a very strong organization. They are overseeing more than 150 health facilities. So this is a major player. And you can see this is the same scatter plot than before for the region, because there is no discrimination aspect. And when you deal with the government, it's okay, because they are lacking many times some money, so there is a need of computer for them, for sure. Or there is a lack of staff because they are not so well paid. So you can already give a fair explanation about why you have this type of variable located in this quadrant. About, back to the Christian Health, this confessional network, stockout. Why is it located here? Because they do not have any scale effect. They are not so well organized, it is well known locally, and they do not have any scale effect in comparison of the government. So they are facing lots of problems with the supply chain. Another type of valuable function embedded into the BioLab, it is the vertical scale. So NGO, of course, they do face lots of troubles with the supply chain. It's even worse than the previous situation with the confessional network, because they are dealing with small quantity of vaccine medicines. The supply chain is the most important factor in which they should put their attention, just to be at the same level. So you see, they are on the top of the vertical scale, which means all the others are well positioned in terms of vaccine wastage, or in terms of how do they efficiently master their project program. It is so fulfilling to have already this type of purely mathematical approach, and you give some very consistent explanation against your understanding of what's going on the field. Takeaway points, back to the beginning. I am a firm believer about BioLab. I do not have any background, but it is so easy to use and to come up with very meaningful explanation about complex problems. You just need a causal model. We do have the theory of change in the framework of health program. And we can also tap into huge data sets. It was not the case in the past. Now we are collecting on a regular basis lots of information. Ministry of Health does know that they are sitting in a goldmine repository. They are a bit reluctant to share it, but it's a question of trustful relationship. We will further introduce Bayesian network to them, and we will see how do they react. So far, we have introduced mainly the mapping services, but just the Bayesian network will come after. As soon as you have fulfilled their expectation, they are much more open-minded to new approaches. And you have glimpsed, I hope so, that through this methodology, this probabilistic structural equation modeling, you can very quickly come up with very relevant recommendation for decision makers. One more slide, or even two more slides, because I do hope next year I will be able to also introduce another type of project, even more ambitious. This is our IT infrastructure. We know that we can tap into the DHIS system just to input our data sets related to what's going on into the health system. We have also another source of information, national survey. Every 5 years, it is organized by UNICEF or MESURE, an American-based organization. They have the demographic health surveys, national-wide survey with GPS points collected, and it is a goldmine repositories. We can merge this type of data sets. We have mobile data collection tool also. We developed it very easy through a mobile phone, and you can collect new information, a tracer system about during house-to-house vaccination program. You know where the vaccinator have been working. And the most exciting one is through a partnership with Pictera. This is a Swiss-based organization, and we can also take benefit of satellite picture because they have their own artificial intelligence algorithm. They can extract livable structure, buildings. So we will be working in slums, in Ghana, in Malawi, and through this algorithm, we can identify potentially where is located this fifth children who is not vaccinated, because through the lodging, through the location of these people, it is located in slums, so we know that they are facing lots of barriers to be vaccinated. But we can come up with a very strong model because according to the type of roof, so for example, we know that it is a social determinants related to poverty, and through poverty, the accessibility to the health system. So I do hope next year we will be capable of showing how did we merge all this information and to bring back very meaningful information to the Ministry of Health, just to target the right place. And another one, I like this one, 2.5 billion people are living on Earth so far. By 2050, 1.5 billion will be added, and 60% of them will be living in urban areas. This is a key challenge. When we are listening about Gavi, and they are ready to fund any type of solution about how to cope with the stakes related to slums worldwide. And maybe it could be an opportunity to use Bayesian network through this merging of all these data sets to select the right place. Thanks very much.